I'll start recording. I meant to record this earlier, but I forgot. So we'll start recording now. Aiden, what about if I wanted to do -1? How would I do that? How would I start that, Aiden?
1?
Yep.
Well, if you want to do -1, you just plug -1 into 5x, right?
Okay, so what would I write?
So you'd write 5 -1 minus 8. And then you'd basically like write down what you get from that. Like, what do you get from that?
Okay. So 5 times -1 being -5. And what's -5 minus 8?
-13.
Okay.
Don't know how in the world I flubbed on that.
Thanks, sir. You guys okay if I leave that last one to you? Is there any questions on how to do that? I'm going to put stars by the ones I'd like to leave to you guys. Audrey's good. The next one, using the graph, is probably something you're not maybe as familiar with. But remember when we talk about a graph, especially a continuous graph like this, that there's points all through here, right? So points, 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 and each of those points has an x value and a y value, right? And so basically what we're trying to do is look for a point with a particular x value and then figure out what its y value is also. So what I'm going to do is take that -3. Zoom in a little bit here, it's easier. So go to where x is -3. And you want to go up or down depending on which way the graph is. But so in this case, I want to go down until I hit that point, right? And then I want to see what its associated y value is. So -3 on the x goes with -6 on the y. So in the same way, 0. So I go to where 0 is on the x-axis, go up or down until I hit the graph. So in this case, down again. And it looks like it's hitting right at -2. So if I was going to write out the coordinates at that point, it'd be 0, -2, right? Or this one would be -3, -6. Like, we're just identifying those points that are on that curve with those particular x values and then what their associated y value is. You guys okay if I leave that last one to you, or do you need anybody else do we need any clarity on that?
But the last one would be 2. Okay.
Zoe, what about 7? Can you read 7 for me? You there, Zoe? Tian, what about you? Can you read 7 for me?
Number 7, right?
Mm-hmm. Just read it.
Okay. P of x of equals 6 minus x.
Okay. What are these things here?
No.
Okay. Does anybody recognize those? What are these bars called? How do we say that? Absolute value. All right, Mason. Remember absolute value, Tian?
What'd you say?
I was talking to Tion. If you remember, now that we got a prompt there. Remember absolute value, Tion?
Sorry, what?
Do you remember what absolute value means? Now that we know what it's called.
Um, isn't it like, I want to say it's something having to do with like the real number or I'm not sure.
Yeah, kind of. Mason, what does this absolute value mean to you, Mason Hare? You're able to recognize it. Do you remember what it does?
Yeah, it's been a while since I've referenced absolute value. I remember it from Algebra 1.
Yeah, it's been a while.
I'm just trying to think. Something about I think it's like negatives turning into like positives or something like that. It can't be a certain type of number when those things are bracketed.
Yeah, something like that. So maybe remember why negatives turn to positives when we talk about absolute value. Like, why is the absolute value of -6 equal to 6?
Because absolute value makes you count places, like physical number places to 0.
Yeah, it's the distance from 0, right? Who is that? That Caleb?
Yeah.
Yeah. So absolute value represents the distance a number is from 0, and so we never measure distances in negatives, so the answer can never be negative. So yeah, the absolute value of a negative number is a positive number. And the absolute value of a positive number is still a positive number. Okay, so that's a little bit of remembering what absolute value means. Thank you for all you guys with your input. Kenzie, if I wanted to do 2 here, how would I start that?
Can you repeat that?
If I just want to do this first, if I want to find out when x is 2, how would I start this problem, Kenzie?
I don't know.
Well, how do we do it up here on 4? What was the first thing we did? I wanted to figure out what 4 was, right? How did I do that? Or when I wanted to figure out what -1 was, how did we do that?
You would set up your equation.
Okay, so what am I going to write to do that down here on number 7?
You'd write P and then your parentheses, and then you'd put 6 in. Or
Like
no, you'd
that?
put 2 in. You'd put 2 in.
Mm-hmm.
And then you close your parentheses, and then you do equals the absolute value of 6 minus 2.
Great. Oops. And make sure when you guys draw those absolute value bars that they are long compared to your numbers, so it doesn't look like 161, right? That these should be, make sure they're nice and tall so that you don't get them confused with ones, right? So, of course, 6 minus 2 is 4, so the absolute value of 4 is 4. All right. Thanks, Kenzie. Do you guys feel like you need to go over that problem anymore, or you feel like you can do the other 2? If I asked you guys to do these 2 on your own, I think you guys can handle that. Okay. Been having a lot of trouble, like, especially if I sit all day, like my legs feel really wonky. I don't know how you guys were doing being young, but being older, so I've been standing all day today. I still feel a little weird, like my hips start to get tired. And my wife was looking online for like one of those little, it's like a little bike basically that you put under your desk and you like sit there and pedal. I feel like I would have trouble like pedaling and riding. I don't know. I can't really do the pat head thing. So let's look at 6 real quick. Samantha, would you read 6 for me?
Yeah. M of x equals, is it the square root
You got it?
of 2x minus 5?
2x minus 5? Okay. So then if I wanted to find that first value, Samantha, how would I do that?
You're gonna put m of 7 equals the square root of 2 times 7 minus 5.
Okay. Of course, 2 times 7 is 14, so I'd have the square root of 14 minus 5, which is the square root of 9.
Mm-hmm.
And Samantha, what's the square root of 9?
3.
3. How do you know that?
Because doesn't like 3 go into 9 3 times?
Okay, so what's special about that? What is it? So if we're looking for a square root, if I say what's the square root of 49, or hey, what's the square root of 121, like what are we looking for there?
What goes into it equally 3 times? Or I don't know.
Yeah, how would we describe square roots to somebody? Anybody else? How do we find the square root of a number? What are we looking for there?
The number multiplied by another number, right?
Not a number multiplied by another number. Because then I could say like the square root of 10 is 2 because 2 times 5 is 10, but that's not the square root of
Number
10.
multiplied by itself, sorry.
There you go.
Yeah, so the number that's been multiplied by itself to get, right? So you're asking yourself, when you say square root, what number times itself is 9, right? So 3 times itself is 9, or 4 times itself is 16, right? So yeah, so when you're square rooting, that's what you're looking for there. Even with this decimal here, the math should work out nicely so that you shouldn't have to, you really shouldn't need a calculator to do the rest of these. Thanks, Aiden. Thanks, Samantha. You guys okay if I leave those two to you? Define square root again. Audrey, is that what you're saying? So a square root is when you try to square root a number, then you're looking for the number that times itself would equal your original number. So if I say, what's the square root of 25? I'm looking for the number that times itself is 25, right? So 5 times 5 is 25. So the square root of 25 is 5. Or if I'm looking for the square root of 100, right? 10 times 10 is 100. So square root of 100 is 10. If I say, what's the square root of 7, you'd be looking for the number that times itself is 7. And there's no nice number for that, right? And so we wouldn't think of as 7 of having 7 is not what's called a perfect square, whereas 9 is a perfect square because it has a whole number answer to that question. Whereas 7 does have a square root, it's just a really gross decimal. Same thing if I said, hey, what's the square root of 20? It does have a square root, it's just a really long decimal that we don't know. So every positive number has a square root. It's just not necessarily something that we would know off the top of our heads. So just looking for the number that when multiplied by itself gives us what this number is called the radicand. That's the name of the number inside of a radical. This symbol is called a radical symbol. This would be called the radicand. Does that help, Audrey? Okay. Last one's pretty similar to 3, and then we're just given a point, right? A set of an x and a y to kind of think about what this function is. I think this one is brings up an interesting situation, though. They're saying, hey, what's the if x is 3, what's the y value associated with 3? So of course we see that our x value here is 3, then our y value is 4. So we say, well, that's whoops. So that's 4, and then they're asking again, later on, for whatever reason, that y, if x was 3, what's the y value? Well, it's still 4. And they're like, well, what if x was 2, right? But there is no point that says 2, whatever, right? That doesn't exist. So that means what we'd say about this, as far as this function goes, is that that function is not defined at that x value. Okay? There is no associated y value with an x value of 2. And so, it's just kind of interesting that we don't always have answers, right? And so with a problem like, relating it back to something that it's like number 3, if I said, we did the table that we did, but if what if I threw another row on there and was like, well, what about 7, right? What's my y value at 7? Well, you go up here and you're like, well, I don't have an x value of 7, so I can't have a y value associated with that. So that would also not be defined now there. Okay, so I wouldn't, I could have certain value not there. So that's what that would look like. If I was looking at the graph, I said, hey, what about, what if I put 7 down here, right? And I said, what about 7 there? All right, what's my y value for 7? And you go over to 7, you're like, oh, the graph never hits 7. So that would also not be defined at 7. All right, it's defined all these places, right? But it's not defined over here. It's not defined over there. There are no points. Okay, so that's kind of what that would look like, for something to be not defined. Then, well, what about these equations, right? Are there numbers that I could plug in or ask about and not get answers, right? Is there any number that I can't multiply by 5? You guys think of a number that you're not allowed to multiply 5 by? I can't, right? Is there any number we can't subtract 8 from? Right, we can do that for any number. So any x value we pick, we could get an associated y value. So I could put all sorts of numbers in this table and we get y values back from them. In the same way with number 7, right? I can plug in any number I want and I'll always get an answer. Okay, so I can take the absolute value of any number. I can take 6, subtract any number, right? That's fine. Now there are numbers we're not allowed to square root. So this would also have places that wouldn't be defined. Like I've asked you to find the x value. If I said, hey, x is -10, you would not be able to do that here. The answer would be undefined. So there are values of x here that would not exist with a y. So just kind of interesting thought that sometimes we don't have answers, right? They're not, values aren't always there for you to see. So anything on the front here you guys want to talk about before we flip to the back? What you need, Kevin? Oh, okay. All right. All right. So if we flip to the back, first thing I want you to notice is that there's 2 big tables. Okay. There's a table labeled F, and there's a table labeled G. And each of these 6 problems here refers to either F or G. So you need to make sure you're not, getting confused. And so if, on any of the F problems, I'm always going to look back at that table. Right? And any of the G problems, I'm always going to look back at this table. Right? So and there was something during 3rd hour I about did to myself. I'm doing an F problem, but I was looking over at the G table. So really easy to do. So just be really careful. Like on 9, 11, 13, make sure you're always going back here to find your answers. And 10, 12, and 14, you're always going back here to find your answers. Okay. So this should seem pretty similar to what we were just doing. Like, I'm giving you essentially a table. This is essentially what a table, but just written differently. It's written as points rather than in a table form. Okay. It's the same idea that here's my X, here's my associated Y, right? Here's my X value, here's my associated Y value. So we're essentially doing that. We won't really be doing, any like a real arithmetic. Basically just looking at the tables, trying to find the answers. Except we've got these little changes to the problem. All right, so notice inside of the function, something is going on. Okay. And so what we need to do here, I'm going to take this X value that they're asking me about, 1, but I have to add 1 to it first. So I'd say, well, what's 1 plus 1? That's, of course, 2. And then I go to look at 2 to get the Y value. So what I'm doing is, look at my hands here, I'm finding a new X, okay? And that's the one that we're going to find the Y for, except for it's not a new X value. Our X value doesn't change. We're just looking at the X value, a different X value to find our Y value, because something's being shifted. And I'll try to clarify that in just a second. Okay, so on the next one, right, our x value is 2, but we're supposed to add 1 to it. So of course that's 3. So I'm looking here. So now the answer is 5. In the same way, if I was looking for the x value for 3, well, 3 plus 1 is 4. So then I look here, and so the answer is 3. We've seen something like this before, and in the moment that I showed you guys this, I said, hey, we're going to see this later, and I'll explain kind of the why of it. I'm still not ready to talk to you guys about the why yet, but this is more of the how, but we'll get there. On the first and second worksheet that we did with all those graphs, you guys did a cubic graph that was shifted off to the right 3 units. And that was x minus 3 cubed was the function we did there. So we were I was talking to you guys a little bit, or just mentioning like that we were going to talk about these shifts later, how those happen, like why they end up doing what they do. Again, we're still not ready to talk to you guys about the why this happens, but I want to see that you figure out how it happens. But yeah, we've seen something kind of like this where there's something happening inside of the function. So notice how that's inside the parentheses. So that's what's happening here. Is this math inside of the parentheses is messing with stuff. So those of you guys that are trying to type this out, you may not want to type all this here. And again, when you guys are doing this on your own, you don't need to do this. Like I'm doing this for you, so you can see where I'm getting these numbers from. But it's not something that you would need to show me. I would just need this from you. If you're able to reference the right number in the table, I have to assume that you know what you're doing. So, okay. So on 10 here, I'm going to start with that value that they're asking me. So x is 3. I'm going to say, well, what's 3 minus 2? So of course that's 1. So I'm going to go to where 1 is. I'm going to go to the other table, right? Because I'm using G now. And then the associated with y value is now 2. Now that you guys have seen that 4 times, is there something that's feeling weird about that? I'm going to do some more of these with you. I just want to know where you are right now, how it's feeling. Okay. Yes, Kylie, you're good. So Audrey, would you walk me through the first one on number 11? You're feeling good about it? How would we do this one?
So are you talking about 11?
Mm-hmm.
So you would do 2 times negative 2, which would be negative 4.
Okay.
And so on the F chart, you look at the negative 4, and that is negative 5. And so that would be the answer for negative 2 on that chart.
Cool. Well put. It's kind of hard to see what I wrote there. Sorry. Let me zoom in a little bit. Caitlin, how are you feeling about things? Good. Okay. What about you, Mason Upton?
I'm feeling all right.
Okay. So Addison, what about this one here on 12? Oops. How would we do that one, Addison?
Why don't you just make it 2
Okay.
and then up on the G one, so it would be 1.
Oops. So -2 gives us 1.
Yeah.
Okay. Sounds good to me. Of course, on the next one you have a negative, right? So that would become a +3, and then you go over here for +3. Cool beans. Jake, what about 1 here? Oops, dang it.
Can you go back to 12?
Yeah, okay. Yeah, let's pause, Jake. What's up, Brian?
One in number 12 real quick.
What's up?
Can we do the second one in number 12?
Okay. What you thinking, Brian?
I'm trying to get it, so I need you to do it so I can understand.
What's it telling us to do?
Minus x.
So not minus x, but negative x, right? And so if our x value is -3, right? What would -3 be? So what's -3, Brian? What do 2 negatives do?
Positive.
Yep. Okay. So then where are you looking with this +3 that we just got? Where should we look?
One of the charts. Is it 4?
Which chart? Which chart should we look at? F or G?
G.
Okay. So at 3, our value is, yeah, just like you said. So at 3, we should have 4. Okay. So you're kind of messing around with your x value. You're manipulating your x value. And then you're going to a new x value here, right? But our x values don't actually change. If I was going to plot that point, it would be 1, 0. If I was going to plot this point, it would be 2, 5. So I'm not using my new x value, right? We're just using it real quick to grab a new number. But then that new number gets associated with the old x value. So it's kind of a little bit of math you do real quick, and you forget about it later. You don't need it anymore. So it's kind of strange. You good, Brian?
Yeah, I'm good.
Okay. So Jake, I think I was asking you about number 13 here.
You plug 1 in to x,
Okay.
and then that becomes 3 minus 5, which is -2.
Okay, so what do we do with that -2?
And then the answer would be 1 for the first row. Or maybe it's column, I don't know.
Careful.
Oh, shoot, I did the wrong board. Okay, hold on. It'd still be -2, so it'd be 2.
2, there you go, yeah. Easy mistake to make, so yeah, just be careful about that. Cool beans. You guys think you're good if I ask you to do the rest of those? Anybody need any clarity on any of those?
I'm still a little confused by the line one, just because it's the only line. I'm talking about the one on the front page.
Oh, the graph one.
Yeah, the graph one. But
okay.
I think all these are pretty good for me.
All right. Yeah, Aiden, if kind of hard because I don't have a set graph already, but so if I had some curve that was doing something, if it was doing something like that, right? And if I said, hey, what's, if this is function f or whatever, so if this is f of x, if I said, hey, what's f of 3, right? So I go over to x is 3, and then I go up to the graph since it's above, and I try to figure out what its associated y value is. So it looks like that's at 4.
All right, that makes sense.
Yeah, if I said, hey, what's f of -2? All right, so I go to where x is -2, and I go down in this case, and it looks like it's at -1. So that would be -1. So yeah, always move along that x-axis, find that spot they're asking you about, and then go up or down to hit the graph, and then find the y value at that point. Again, basically what you're trying to do is find the coordinates of this point. So -2 what, right? Here's 4 what? Where's the point at 4? Right? What's the y value of the point at 4? Really a different way of saying the question.
All right, that makes sense. Thank
Cool.
you.
Yeah, man. So 15, 16, in your words, all right? We've been talking about function composition on Thursday and Friday. So kind of think about what we did last week, at the end of last week. What did function composition mean, right? And that's when we say function composition, I'm talking about this right here. This is function composition. And then this one's kind of, it's not something we've talked about. I'm just trying to see what you guys think, right? If you reverse the order, would you always get the same answers, right? So let me know what you guys think about those. It'll be interesting to hear what you guys have to say. But how do we use function composition in this way? And so we're still using those same two tables, the f and g that are up above, okay? So f of g of x, okay? And so this says, if we plug in 1, so if I'm looking at this one, f of g of 1, right? And so what did they mean? How did we do that, right? How did we find f of g of 1 when we had functions, right? We had something to plug it into. Well, we started off by saying, well, the first thing I'm going to do is find g of 1, because that's on the inside. Well, how am I going to figure out what g of 1 is, right? Well, I'm going to go up to the table and see g of 1 is 2. So g of 1 is 2. Well, what did we do with that number once we had it, right? We took that number, zoom back in here, and we took that 2 and we said, well, f of, and now that 2 went over here, right? So now we're finding f of 2, and go back to the tables, but make sure you go back to the f table now. So f of 2 is 0. So f of 2 is 0. And that 0 goes up there. So you're going to pull that function composition apart, right? That have the function inside of the other function. We always started on that middle part. Figure out what that value is, plug that value into the outside function. Whatever the answer is there, that's the final value. June, do you think you could walk me through one? If I ask you to do this one?
The first one for 18?
Yes.
Okay. So, you would just have to, okay, so it would be g of f of 3.
G of f of -3?
Or, yeah, -3. Negative
Okay.
3.
So where do I go first? What was the first thing I did?
Oh, find g and f.
The first thing I did was the inside. Right? That's where I started. So where are you going to start?
F.
Okay. So I want you to find what? F of -3?
Yes.
So what's f of -3?
That is -1.
Okay, so f of -3 is -1. So now that we know that, what do you do with that -1?
So it would be -1 times a -3. Wait.
We found g of 1 here, got 2. What did I do with my 2?
Mr. Baker, it's 222 or 223. 223.
Okay, thanks, Mason.
Yep.
So June, what did I do with my 2? Once I found that g of 1 was 2, what did I do with it?
Oh, you inserted it
into. Okay, so what are you going to do with your -1?
Insert it into G.
Okay, so plug into G. So what's G of -1?
G of -1 is -4.
-4. All right, so G of -1 is -4. So that means our answer is -4. Okay. So I'd like you guys to try those last three also, finish those up. I know they're a little bit harder with the function composition stuff. And I'll post this video and once I have it and these notes. So that'll go, the notes will go faster, but all this stuff that I've written here will be posted up on the Google Classroom in case you needed to see it again. Okay, but all these ones with the red stars I want you guys to do on your own. Hopefully you can get that finished pretty quick and probably do tomorrow.
How do I save this into my drive?
Wonderful question. I saw up in the top right there was like either the three dots or there's something that like an export. You might want to try exporting it, or somebody else was saying something about it, how it already saved their drive.
Oh yeah. It says download it. Okay. Yeah, I found it.
Yeah, you might just download it. That's something I haven't gotten to play with yet, Audrey. So.
All right, I got it.
Cool.